Hello guys, so now I'm going to learn about what is type of systems. So actually there are four types of systems. So this is actually for myself to do revision. So there are four types of system: memory or memoryless, causal or non-causal, linear or non-linear, and time invariant or time varying. Okay, so we continue with about what is a causal system. Okay, so a causal system is like the time value when is always zero and the system will not have any future output. Okay, let's say I have an example xt. Let's say, so to determine a system is a causal system or not, okay, so I will use t equals to 0, t equals to 1, and t equal to -1, so that I can know that whether the system got future output or not. If the system got future output, then the system is a non-causal system. So if the if the system got should be not have future output, then the system is considered as causal system. Okay, so we take let question 1 as an example. xt so we substitute 0, x 0 minus okay, so we substitute 0 first. X 0 minus x minus 1. Okay, so if we substitute t as 0, we can see that this is actually a non-causal system. Why? Because when t equals to 0, the system will output only x0 and x -1. Okay, so let's look at an example which is a causal system. So okay, non-causal system. Okay, so let's take this as example. Okay, so if I substitute y 1, let's say t equals to 1, it will output x2. Yeah, so this is actually a non-causal system because the system outputs an output which is when t equals 2. So this is a non-causal system. Okay, so as a quick reminder, when the system got future output, then the system is considered as non-causal system. Okay, yeah, so the system. Okay, so now we learn about linear system and non-linear system. Okay, so a system whose output is proportional to its input and satisfies the following properties. So additive properties, scaling homogeneity properties, and superposition properties. Okay, so let's look at an example. So linearity. Okay, so when we put a system into a function, okay, let's say okay, consider 3. Okay, so we look at example so that it is easier for us to understand. Okay, so let's say txt x1t equals to y1t, okay, equals to y2t. Okay, let's say for example, so let me read. Okay, additive properties x1t, okay, tx1n plus tx2n. Okay, so if it, okay, so let's say to check a system is linear or not, we need to use series or cascade connection and also parallel connection. If the system output the same in series or cascade connection and parallel connection, then the system is considered as linear. Okay, so x1n plus x2n. Okay, so series or cascade, so means that we put the input into one function. Okay, x1n So the function is t. So the input is inside this t. So this is series. Okay, so for YBN, so parallel connection is the input put into two functions that are the same, which is t. So it will become tx1n plus tx2n. Okay, so in this example, the output is actually the same. Therefore, this system is actually considered as linear system. Okay, so we try to do question 2. Okay, so web. Okay, so I lock my screen first so that it won't rotate. Okay, question 2. Yt equals to 10xt plus 5. So determine the linear is the system is linear or non-linear. Okay, so we take y bar t first. So y bar t, we always do series lah. So series, we always use one function only for series, and parallel we use two functions. Okay, so series. So how should we start? Okay, x1t equals to y1t equals to 10x1t plus 5. Okay, x2t equals to y2t equals to 10x2t plus 5. Okay, so we let x1t, we let the xt equals to x1t and x2t, so that it has two inputs lah. Okay, so we let the inputs equal x1t and x2t. Okay, so after that, what should we do? So we try to do with series connection first. So remember, when I say series connection, means the input is put into the same function. So 10xt, so the input should be x1t plus x2t. Okay, the input is in the same function. Okay, so this is a series. So let's see parallel. The input is put into different functions. So how should we do it? Okay, so how should we do it? Okay, so same, we also use 10x1t plus x2t. So the xt, so we substitute xt equals to s1t plus x2t. Okay, so this is how we do it. Okay, so seems like we get the same result. Hence, this system is a linear system. But why did I say non-linear system? Right, oh, yep, sorry, my fault. So the input is actually put into, so this is actually so the first example that we done, the highlighted example that we done is actually a parallel connection. Sorry, my fault. A parallel connection means what? I mean a series connection. A series connection means the input will be set into one function. So 10, so they put into function 10. So this is actually a function. Okay, so to make it to become a parallel input, so we need to separate 10x1t plus 10x2t. Okay, so plus 5. Okay, so okay, oh, okay, so when the system goes to a parallel connection, so how does it look like? Okay, so we have y1t. Y1t is a new function for x1t lah. So 10x1t plus 5. Okay, so y2t, we also have a new function which is 10x2t plus 5. Okay, so if the two functions combine together, it will become y2 bar equals to 10x1t plus 10x2t plus 10. So in this example, we can see that the series, this is actually a non-linear system. Okay, so let's try to solve question number 3. Okay, so we have got the idea. So we need to solve step by step. Okay, so 2xn minus 1. Okay, so to determine the system is linear or not, okay, so the first step is we see whether we insert x1n plus x2n into a function first. Okay, so let's set xn equals to x1n plus x2n. So xn minus 1, we also make it become two function. I mean two inputs. So this is actually a series connection because the inputs is undergo the same function. Okay. Okay, so yn. Okay, so this is series. We represent this as series. X. Okay, so it will become x1n plus x2n plus 2x1n minus 1. Okay, 2x1n minus 1 plus x2n minus 1. Okay, so this is series that we do. So to do parallel, so we can set it as we have x1n, so y1 we have x1n plus 2x1n minus 1. y2 we have x2n plus 2x2n minus 1. Okay, so the two functions combine together, so this is parallel. So it will become x1n plus x2n plus 2x1n minus 1 plus 2x2n minus 1. Okay, so we can see that this is actually a linear system because the y bar equals to y bar bar. Okay, so this is how we do check whether a system is linear or non-linear. Okay, so I hope everything is okay. So let us summarize a bit. So actually we can conclude that when a system got a constant means when a system got a constant like +5, okay, when a system got a constant like +5, then the system actually will become then when we want to do parallel connection, the constant will add up together, and in a result it will not same as the series connection because in series connection the constant actually won't add up together. Okay, so let's look at question 4 so that we can generalize whether a square will affect the linearity or not. Okay, so as Sm x1n plus x2n into xn. Okay, so y bar n, so this is series, so we call it y bar n equals to x1n plus x2n square. Okay, so this is x1n plus x2n square. How about y bar n actually equals to, okay, so let's say it become x1n square and I mean y1n, so y2n equals to x2n square. So when we do parallel, we can see that y bar is actually not equal to y bar because y bar is actually x1n square plus x2n square. So it is not same as y bar n. So this is not a non-linear system. So okay, so actually I have done summary. For if our input is xt and then substitute into y1 and y2, so y bar we are actually doing parallel connection. Yep. Okay, so that's what I mean. Okay, so now we are heading towards time invariant system. Okay, so the time invariant system is also called fixed system, whose parameters does not change with time. A time shift in the input signal uses the same time shift the output signal. Okay, so when we say time invariant means the time is not variant. So time is not variant means the time is not changing. Means the input signal will actually so means the input signal at a specific time will actually produce the output signal at that specific time lah. Means there is no current, or how to say, there is no future value or somehow other value lah. Okay, so there are 3 steps. Okay, so delay xt by k. Okay, so delay xt by k first, t minus k. So the first step is delay xt by k, and the second step is substitute t minus k into the function. Okay, so if 1 and 2 is same, I mean equation 1 and equation 2 is same, then the system is called a time invariant system, because the time shift, like the system time shift, when the system has face a time shift, actually the output will also face the same time shift lah, like the input. Okay, so let's take example 1. So if we want to perform time shift, we actually substitute t minus k into the function of x lah. Okay, so we delay the t, we delay the xt by k lah. Okay, so if we want to delay, instead if we want to like make it earlier, also can lah, I think plus. Okay, using plus, but in our case we use delay lah. So y n, okay, x n square minus k. But if we substitute y and k, so I do equation 2 now. Okay, so y and k, but if we substitute y and k, it will actually become y n minus k squared. So you see, this equation 1 and this equation 2 actually is not the same. Okay, so therefore we can conclude that this is time varying system, because the time will change. I mean the output signal is actually affected by the time shift. Okay, so the input signal will not use the same time shift in the output signal lah, in this how to say, in this example. Okay, so if we input negative k, but actually the time shift will around n minus k squared. Okay, so time invariant, no problem. So now we go to the last system, which is memory and memoryless. Okay, so memoryless, if the output at t0 depends on the input time t0 only, regardless the input is before or after t0, the output is a function of the input at only present time. So memoryless system is also known as static system. Okay, so the system don't have memory lah. Okay, so if the output at time t0 depends on the input at time t0 only, regardless the inputs before or after t0, the output is a function of the input at only present time. Means the system does not store any memory, because the input at t0 and the output still at t0. Okay, so this is input t0. Okay, so this is a memoryless system. Why? Because when we input 1, if y1 actually equals to x squared 1 plus x1, so if our time is 1, it will produce the output at 1 lah. Okay, so let's see this example. If we input okay, so memory system is also known as dynamic system, and the output t0 is depends on the input at time t0 lah. Okay, and also inputs before and after t0. Okay, so let's see, if we input t0 equals to 1, t0 equals to 1, and the system will become x minus 1. So actually the system produce an output when t equals to negative 1 lah. Okay, So actually this is a memory system lah. Okay, let's say question 2. If we input y1 equals to x1 plus x2, okay, so this is actually also a memory system, because y1, you will when we substitute t equals to 1, it will produce a future signal, which is x2, which is when the signal is at 2 lah. Okay, so I think that's all. Okay, so I think that's all. So as a conclusion, we can conclude that Clausen system is a system that will not produce any future output, and the linear system is we need to use series and parallel cascade. So series cascade is actually using xn equals to x1n plus x2n, and we substitute into the system. But for parallel connection, the system, we need to y1n equals to x1n and y2n equals to x2n, and with y1 plus y2 is actually equals to function y bar bar. So if y bar bar equals to y bar, then everything is okay. So it is linear. Okay, so we also go to time invariant system. So time invariant system is actually when delay by t minus k or t minus x, t minus z. Okay, and if the okay, so after that, if we substitute t minus k and we check that whether the equation is equal or not, if it is equal, means the system is time invariant, because our output signal and input signal will have the same time shift. But if it is not equal, means the output signal and the input signal will have a different time shift, means it is a time variant system. Okay, so lastly we go to memory system. So memory system, so if a system always output a current value, means this is a non-memory system lah, memoryless system. So this is also a static system. But if a system output at time t0 depend on the input at time t0 and also inputs before and after t0, okay, so this is actually a memory system lah. Okay, I think let's say 0, 1. Okay, so this is actually a memory system, because if we substitute 0, 1, and the function will actually output the output signal at when time is actually equals to 2 seconds instead of 1 second. Okay, so I think that's all for type of signal. Thanks.